The Shape of the Data, our tutorial. In the Shape of the Data lecture, Allison explored the distributions of the data sets we are now familiar with through the use of a new graphical measure, the histogram. We will produce histograms for the life expectancy dataset, the skeletal remains, and the salaries for the New York Red Bulls. Again, we will read in the life expectancy data and name the second column with the life expectancies life EXP. Let's investigate R's default histogram. With the command hist, we obtain a basic histogram of the data. Notice that R automatically chooses how many bins to create, gives the histogram a main title, and names the x-axis after the variable name. We can change a few of these options to get a better looking histogram that is easier to read and more informative. We can now specify that we would like the histogram to contain only 5 bins, with the argument breaks is equal to 5. Then we can change the label of the x-axis. And finally, we can change the title of the histogram. It is always advised to go through the trouble of renaming the axes or the main title, because although life EXP is a variable we know very well, to a casual reader this variable name can be very confusing and oftentimes misleading. What happens when we change the number of bins? As Allison pointed out, it might not be a good idea to do so, since increasing the number of bins can sometimes make the histogram look more noisy, and it will definitely make it harder to determine its shape. For comparative purposes, we can also reproduce the horizontal box plot of the life expectancies, with the extra argument horizontal is equal to true. Our final investigation into the shape of this dataset will be with the 5-number summary. Here we can follow Allison's reasoning as to why the data is left skewed. We can also see right away that the mean is less than the median, which should also be a clear indication. For our second dataset, the skeletal remains, we can follow a similar pattern in our investigation. First, we will begin with a histogram of the differences, DG difference, allowing R to set the default number of bins, but renaming the x-axis. And again, we will want to compare the histogram with the horizontal box plot. Finally, with the use of summary statistics, we can see that the data is fairly symmetric. Our last example will use the salaries of the New York Red Bulls. For the histogram, we will want to use the salaries in thousands of dollars, so we will graph NY salaries divided by 1,000. We will also specify, with breaks is equal to 24, that we wish to have 24 bins, so that we get a better sense of where the data lies. But even with so many bins, we still can't get a good grasp on the shape of the data because of the 2 extreme observations on the far right. To remove these 2 outliers, first we will create a new variable NY salaries underscore outliers removed and set it equal to the sorted salaries from observation 1 to 23. This will remove observations 24 and 25, which are the highest 2 salaries. The histogram of this new variable, in thousands of dollars, shows more clearly that the data is in fact right skewed. The horizontal box plot confirms this as well, and so do the summary statistics in the 5-number summary. As a final note, sometimes depending on the data, the summary command will have the resulting statistics accurate to a specific number of digits. You might have noticed that our mean of 119,900 does not agree with Allison's mean from the lecture of 119,904. We can specify in the summary command how many digits the answer should be accurate to. In our example, since the highest salary with the outliers removed has only 6 digits, we can specify digits is equal to 6 in the summary command. And for a more accurate answer still, we can choose to be accurate to 7 or even 8 digits.